Before deriving any formula, I want to explain the reason for the resistance as well as conductance. I already said conductor or especially metal means it is the ocean of free electrons in which positively charged ions are immersed. The ions is due to what? Atom, metal atom, it gives out its outermost electrons, they are free to go within the metal. Therefore, ions, positive ions are left back. Okay. Now, what is the cause for the resistance as well as conductance? We take one simple circuit like this, conductor connected to the cell. To make it clear, let us say it is 6 volts. It need not be 6 volts every time, but to make it clear I am taking it as 6 volts. Therefore, this potential difference appears here, it is also 6 volts, and this is positive end, it is negative end. And here these are the atoms, actually they are the ions, but we can say here we can say that these are the atoms. Now, we take one free electron, think that here you have got a one free electron. This free electron is repelled by the negative end, attracted by positive end. Therefore, electron is trying to go in this direction. Therefore, electron is moving like this, but as it moves in this direction, it undergoes collision with the atom or ion. These are the ions. So, electron is due to the collision, it is scattered, remember, its direction of motion changes. So, electron comes like this, and again electron when it comes like this, it may collide with another atom, therefore, it changes the direction, it goes like this. And from there, electron after the collision, it may go like this, and from here electron may go like this. Because of the collision, it changes the direction, it changes the momentum also, its momentum also changes. Therefore, now look here, electron is going from negative end to positive end, but if you look at the path, can it go easily? No. That electron has to undergo collision with the atoms, and in the collision it loses the energy, that energy is given to the atoms. Due to that, atoms are vibrating with the more amplitude. Last year you studied translational degree of freedom, rotational degree of freedom, vibrational degree of freedom. Therefore, due to the collision, that electron loses the energy, and that energy is given to the atoms. Atoms are vibrating with the more vibration, therefore, their vibrational energy increases, that increases the temperature also. Hence, electric current always produces heating effect. Now, look here, electrons are allowed to go from negative to positive, that part is known as conductance. At the same time, electrons are allowed, but they are not allowed easily, they have to follow zigzag path. When they follow the zigzag path, they take more time, that part is known as resistance, that is known as resistance. Just like, let us say if you want to cross the road, let us say it is the highway, and it is the point A, it is the point B. During night time you can cross the highway easily, because the traffic is less, straight away you can go A to B. If you can cross A, if you can go A to B easily means resistance is less. You are taking less time. Conductance is more. Easily you can go from A to B during the night time. But what about during daytime? During daytime in this highway a lot of traffic is there. Can you go from A to B easily? No, you have to wait. It takes more time. You have to get into the road and one vehicle may come, there you have to stop. Again another vehicle comes, you have to stop. Once vehicle goes, you have to go little further ahead. Again you have to stop, you have to look both the sides. So definitely resistance is more. During the daytime it is very difficult to go from A to B. Resistance is more. It takes more time for you to cross the road. Conductance is less. Same logic here. Now I want to explain the term known as drift velocity, because already in the beginning I said we try to relate current with the current is the macroscopic value. Current is what? Macroscopic value. Potential difference is a macroscopic value. I want to relate current with the microscopic, means with the movement of electrons, individual electrons. So for that, first of all we try to understand one term known as drift velocity. Drift velocity. What is drift velocity? Try to understand this. Drift velocity. Drift velocity of free electrons. Now, what is a drift velocity? See, you want to go in one direction, but unknowingly due to some other factor, if you go in another direction, we can say drifting. The best example is person crossing the river. Think that it is the river, this is the downstream of the river flows down in this direction, and a person wants to go from A to B from one bank of the river to the another side, A to B directly. River is flowing down and person is not familiar. He knows how to swim in a swimming pool, but not in a river. If that person gets into water and he is swimming A to B directly, so he gets into water and he is swimming directly like this. But my question is, if he gets into water directly and if he is swimming like this, can he reach the point B? Definitely answer is no. What is the reason for that? As he is swimming from A to B, water flow will take him down. Therefore, he is going like this. He reaches the point C. Now, this is what we say drifting. He wants to go from A to B, but the water current will take him down, he reaches the point C. So, drifting. This is one beautiful example for drifting. And another one, landing of the aeroplane. So, what is that? Think that it is the runway, just think that runway, and pilot is taking the aeroplane directly to the runway so that he can land safely. The normal days it is a simple, pilot can take the aeroplane to the runway and can land. But think of a particular day where there is a crosswind. What is the meaning of that? See here, wind is blown from this side to this side, wind is blowing like this. From my left side to right side, wind is blown like this, and pilot is not aware of this crosswind. So, pilot is directly taking the aeroplane to the runway, but as he is taking the aeroplane to the runway, wind will take him down, just like a flow of current, water there. So, the wind will take the aeroplane to some other point. This is the direction of wind. So, automatically wind will take the aeroplane here, and is it not dangerous? So, pilot has to make necessary adjustment so that every time he can approach the runway properly. Actually, he has to take the aeroplane in this direction. If aeroplane is taken in this direction, wind will take it down, so he can reach the runway. and related to this you can see number of videos in internet, remember. So, drifting means you want to go in one direction, but unknowingly you are taken to another direction due to some force. Same thing happens here. Electrons are in random motion, thermal motion. Those electrons, they want to go in one direction, but because of the force, electrostatic force, they are going in another direction. So, we derive the formula for that. So, drift velocity. Conductor is connected to the cell, and to make it clear, I am considering 6 volts. This 6 volts is applied between two ends. It need not be 6 volts. So, do not write this value in exam. It is just for explanation purpose to make it clear. So, this 6 volts appears across the ends of the conductor, and now I am taking uniform conductor. What is the meaning of uniform conductor? Where area of cross section remains same. Here we take one free electron, it is in random motion. For time being, the electron is here. Once you connect the conductor to the cell provides potential difference, and that potential difference produces electric field. Produces what? Electric field. And we know the direction of the electric field is always from positive to negative. Therefore, this is the direction of the electric field. It produces the electric field E. Now, the question is, this electric field, this field is produced inside the conductor. The question is, can electric field be there inside the conductor? Because in the previous topic, we say electric field inside the charged conductor is 0. We studied about that. Gauss theorem, application of Gauss theorem. Gauss theorem is applied to the spherical conductor or spherical shell, where field is outside, just outside is there, but what is the field inside? 0. Inside the conductor field is 0, but here we say electric field is existing. It looks like a contradiction. There we say field is 0, but here we say field is existing, but both the statements are correct. In the previous topic, it is the electrostatics, where charge is in the state of rest, where field inside the conductor is 0, but here charge is in the state of flow, electric field exits inside the conductor, and this is the direction of electric field. It is the uniform wire, therefore field is uniform. I want to find out what is the equation for E. Let us say L is the length of the conductor, L is the length of the conductor and V is the potential difference. Now we know in the previous topic, electric field is equal to minus dV by dx. Electric field is equal to negative of the potential gradient, and here we take only magnitude dV by dx. What is dV? dV is the potential difference. What is the potential difference here? V. And dx, distance between the 2 points in that derivation. Here length of the conductor L. Therefore, E equal to, it is V by L. Very important equation. Therefore, inside the conductor uniform electric field is existing, and it is given by the formula potential difference divided by length of the conductor. Because of this electric field, electrons are experiencing force, and it is given by the formula F equal to Q naught into E. This is also taken from the first topic. Electrostatic force is equal to test charge multiplied by electric field. Now, instead of test charge Q naught, we take free electrons. What is the charge of the free electron? Minus E. Therefore, F is equal to, it is minus E into E. This is the equation for force experienced by the free electrons due to the electric field inside the conductor. And what is the significance of minus sign? Minus sign indicates that electric field and force are in the opposite direction. Therefore, the direction of the force must be towards positive end. This is the direction of the force. Look here, electric field is in one direction, force is in the opposite direction. Therefore, in vector form you have got a minus sign. And do not confuse this minus sign, because generally in first PU, whenever you have got a minus sign for the force, we say retarding force like that. It is not retarding force. Here minus sign, its meaning is different. It says that field and force are opposite. Therefore, all the free electrons are trying to move in this direction. Means along with the thermal motion, electrons, they have got a accelerated motion due to this force. Due to both, they are slowly going from negative end to positive end, and they undergo collision. In the collision, they lose their energy, they lose their velocity, they change their direction. Therefore, they take more time. Okay. This is the formula. Now, we can take magnitude of this. If you take magnitude of F, then minus sign can be neglected. It is E into E. And what is E? V by L. Therefore, it is V, E into V by L. This is one more equation for magnitude. Now, I want to derive the formula for drift velocity. From this, we can discuss about drift velocity, but you have to remember these two equations. It is these two equations are very useful for the study. Think that you have got a conductor, and already I said electrons are in the random motion, and that random motion nothing but due to temperature. So, this is one of the free electron, and its thermal velocity is u1. See here, its thermal velocity is u1 means do not say that it goes like this and it comes out of the metal, wrong. For time being, this is the thermal velocity, electron is trying to go like this, it undergoes collision, but at one instant it is going like this with the thermal velocity u1, but after some time it changes. Its direction changes, value changes due to collision. At one instant it is u1 like this, and I am taking another electron like this. Thermal velocity, let us say it is u2. So, we can take a number of electrons, and already I said in the beginning, I explained average thermal velocity is equal to u1 plus vector u1 plus vector u2 plus vector un divided by n is equal to 0, where n is the number of free electrons inside the conductor. Now, these are the thermal velocities. Along with thermal velocity, thermal motion, you have got accelerated motion due to electrostatic force F. So, because of the force, electrons are moving from negative to positive. So, there are two types of motions, one thermal, another one is accelerated motion towards the positive end. Due to that, electrons, they change their direction. Just like a person is trying to cross the river from A to B, as I explained, but water current will take him down. He goes somewhere else. Same logic. Electron is trying to go like this, but it is experiencing force towards the positive end. Electron cannot go like this. Instead of that, electron goes like this. Instead of undergoing collision here, electron may undergo collision here. This electron is trying to go like this, but due to force towards the positive end, electron cannot go like this. It is coming like this due to thermal motion, but it comes like this. It may end up here. Instead of ending here, it may undergo collision here. Now, in first PU, you studied for motion in a straight line, V is equal to U plus AT, or V naught is equal to U naught plus AT. And in vector form, it is like this, vector V equal to vector U plus vector A into T. I want to use this formula. Actually, if you look at this, it is nothing but triangle of vector addition. If it is a motion along straight line, either vector you have to add in terms of magnitude, or you have to subtract if they are in the opposite direction. That is why we ignore that symbol, V equal to U plus AT. But actually it is the triangle of vector addition. How? Look here. Think that it is vector U plus this is another vector A into T, vector U plus A into T, it is vector V. So, vector V is nothing but sum of these two vectors. This is also a vector, remember. So, I want to apply that logic, this triangle of vector addition here. Look here, it is U1 plus A into T1. So, this is now taken as vector A into T1. What is the T1 here? T1 means it is the time taken by this electron to go from here to here, and think that here it undergoes collision, because electrons are in the random collision, just like gas molecules. Last year we studied in kinetic theory of gases, all the gas molecules are in a random motion, they undergo collision. Same logic. Electron cannot go straight, it travels up to some time, it undergoes collision. So, think that it goes from here to here. From here to here, what is the time taken? T1. And here, this is now taken as vector V1. It is the velocity of the first electron, velocity of the first electron due to thermal motion and accelerated motion due to electric field. Similarly, here this is U2, and here this is now taken as A, vector A into T2, and here it is V2, velocity of the second electron due to thermal motion and due to accelerated motion. What is the T2? T2 is the time taken by the second electron to travel from here to here. Think that here it undergoes collision. Actually, otherwise here it will undergo collision in the absence of electric field. In presence of electric field, here it will undergo collision. So, it is applicable for all the free electrons. It is applicable for all the free electrons. Therefore, now, if we apply this equation here for the free electrons, we can write like this: V1, vector V1, velocity of the first electron due to thermal motion and due to accelerated motion between the two collisions, is equal to U1 plus vector A into T1. For the second electron V2, U2 plus vector A into T2. For the third electron V3, U3 plus vector A into T3. Now, you may ask one question: why it is vector A, vector A, vector A everywhere? Can it be A1, A2, A3? No, this is the uniform wire. For the uniform wire, acceleration of all the electrons must be same. The reason is acceleration is given by the formula vector F by m, which is equal to minus E by m, where m is the mass of the electron. Where m is what? Mass of the electron. See here, minus E by m. I said for the uniform wire, E will be same, constant. Charge on the electron is a constant, mass of the electron is a constant. Therefore, as long as electric field is constant, acceleration will be constant. Means for the uniform wire, for all the free electrons, acceleration is same. Don't write A1, A2, A3, no. But time of collision, that differs, T1, T2, T3, it need not be same. It is the chance of that particular electron. One electron may take more time for collision, another electron may undergo collision quickly. Therefore, time of collision need not be same. Now, like this, Vn, velocity of the nth electron, is equal to Un plus vector A into Tn. I want to find out what is the average velocity due to thermal motion and accelerated motion due to electric field. So, now average velocity V average is equal to V1 plus V2 etc. up to Vn divided by n. So, V average is equal to, what is V1? U1 plus vector A into T1 plus U2 plus vector A into T2 etc. Un plus vector A into Tn divided by n, or V average equal to, separate U1, U2, U3 etc. U1 plus vector U2 plus vector Un divided by n. Separate this one plus. Now, A is a common term here, vector A, take it outside, vector A. What is remaining? T1 plus T2 plus T3 up to Tn by n. Now, tell me what is the answer of this part. Average velocity due to thermal motion is always 0. Average velocity due to thermal motion is always 0. Therefore, first part is 0. So, V average is equal to 0. You can write 0 vector, no problem, into A. Now, look at this, T1 plus T2 plus T3 up to Tn by n. This is the interval between the two successive collisions suffered by the free electrons. And is it not average time interval between the two successive collisions of all the free electrons? Therefore, this is known as average time interval between the two successive collisions of all the electrons. It is taken as relaxation time, written as tau, where tau is the relaxation time, where tau is the relaxation time, and tau is equal to T1 plus T2 up to Tn by n, T1 plus T2 plus up to Tn by n. So, average velocity of the free electrons due to electric field is equal to A into tau. This average velocity is now known as the drift velocity. This average velocity is known as drift velocity. and its symbol is Vd is equal to vector A into tau. Therefore, what is drift velocity? Drift velocity is the average velocity of the free electrons under the influence of electric field, and it is a one more question. If you take old question paper, you can see define drift velocity. They never ask what is drift velocity, they say define drift velocity. How to define drift velocity? Drift velocity is defined as the average velocity of the free electron under the influence of electric field. This is the equation. Now, we can substitute for A, because what is the formula for A? Already we know, I explained. So, next step, Vd is equal to minus, what is the equation for A? Minus EE by m into tau. This is the formula for drift velocity. And be careful, this minus sign indicates that, here it must be better, okay. Minus sign indicates that electric field and drift velocity are in the opposite direction. Look here, minus sign. It is very clear from this drawing also. Electric field is from positive to negative in this direction, electric field. Electrons are going in the opposite direction. Therefore, electric field and drift velocity are always opposite with respect to what? Electrons. That is the significance of this minus sign. Now, for the further discussion, we take only magnitude. If you take the magnitude, we can ignore that minus sign. Therefore, we can say drift speed. Simply we can say drift speed mod of Vd is equal to, ignore this minus sign, therefore it is EE by m into tau. This is the formula. Now, why we have to take this formula? The reason is simple, current is a scalar quantity, therefore sign is not required, minus sign is not required, minus sign indicating direction. Therefore, for all further discussion, we go for this equation, we use this equation throughout. Now, relaxation time, tau, relaxation time. Again, you can expect in exam for this definition, define relaxation time. So, how to define relaxation time? Relaxation time is defined as average time interval between the two successive collisions of the free electrons, and it is a very small value, extremely small value. Relaxation time is generally 10 to the power minus 14 seconds. Just think of that, 10 to the power minus 14 seconds. This is one point you have to remember. Thermal velocity of the electrons, its value at room temperature is generally 10 to the power 5 meter per second. It is extremely high value, thermal velocity. Thermal velocity is of this much order, 10 to the power 5 meter per second. But what is its contribution for the current? 0. Whether there is electric field or not, average velocity of thermal motion is 0. Therefore, even though it is extremely high velocity thermal motion, its contribution towards the electric current is 0. On the contrary, drift speed, it is extremely small value. Its order is 10 to the power minus 4 meter per second, or roughly 0.1 millimeter per second. It is extremely small value. its order is 10 to the power minus 4 roughly. But even though it is a very small velocity, because of this extremely small velocity, we have got a electric current. Therefore, electric current is due to drift velocity, not due to thermal motion. Now, we see one important derivation, that is electric current in terms of drift velocity. You can expect in annual exam for 3 marks, or even in some case if some other questions are added, you can expect even for 5 marks. So, expression for electric current in terms of drift velocity. So, electric current in terms of drift velocity. It is the conductor, uniform conductor connected to the cell, which provides potential difference, and the length of the conductor is L. Area of cross section of the conductor is A. A means area of cross section, and this is the positive end, this is negative. And here we take one free electron. Of course, we have got a billions of free electron, out of that I am taking one. This is the direction of electric field, it is the direction of force, and this is the direction of drift speed also, drift velocity, not speed, drift velocity. Okay. And here current is I in the circuit. I want to derive the formula for current in terms of drift speed, current and drift speed. How to derive the equation? Very simple. Now, what is the basic equation for current? Current is equal to Q by T. Now, what is Q? Q is the amount of charge crossing the conductor, T is the time taken. So, first of all we try to find out how much charge is there in this conductor which is ready to cross it if you apply the PD. Next step, we try to find out what is the time taken by that amount of charge to cross the conductor. So, in the beginning you try to find out Q, and next we find out T, time taken by the charge to cross the conductor. How to find out amount of charge inside the conductor which is ready to cross? It is known as free charge. So, what is the meaning of free charge? Free charge means it is the amount of charge present in the conductor which is ready to cross the conductor whenever PD is applied. Free charge. How to calculate? It is some 2 or 3 steps. For that, first of all I want to calculate volume of the conductor. We find out volume of the conductor. What is the equation for volume of the conductor? It is a cylindrical wire, uniform wire. Therefore, volume of the conductor is equal to area of cross section into length. So, volume of the conductor. Now, it contains so many free electrons, but that number of free electrons within the conductor is the property of that material. So, we define a term known as free electron density. What is free electron density? It is the number of free electrons in unit volume of the conductor. It is the property of that material. From metal to metal, that value changes. Number of electrons in cubic meter known as free electron density. It is the property of that material. So, let N be the number of free electrons per unit volume of the conductor. Unit volume of the conductor, also known as free electron density. Okay. Means if you take 1 cubic meter, think that it is 1 cubic meter. How many electrons are there? N electrons are there, N free electrons. If you take 2 cubic meter, means double of this volume, how many free electrons? 2n. If you take 3 cubic meter, how many free electrons? 3n. If you take 10 cubic meter of the metal, how many electrons? It is 10 into n. Or if you take A into L, this much cubic meter of the material, AL means volume of the conductor, then how many free electrons are there? It is AL into n. AL into n. Okay, I think all of you got this idea. For 1 cubic meter, how many electrons? N. If it is 2 cubic meter, double. If it is 3 cubic meter, 3 times. If it is A into L cubic meter, how many free electrons? AL into N. Therefore, within this conductor, how many free electrons are there? AL into N. Next step, number of free electrons inside the conductor. Number of free electrons inside the conductor. N into A into N. That much free electrons are there. And what is the charge of each electron? Minus E. Therefore, what is the total free charge inside the conductor? Total free charge inside the conductor is equal to total number of free electrons multiplied by minus E. Therefore, total free charge inside the conductor. NaL into minus E. But actually we will ignore this minus sign. The reason is we discuss electric current as a flow of positive charge. Even the electrons are flowing, moving inside the conductor, but we discuss everything in terms of flow of positive charge. Therefore, ignore the minus sign, you write E. So, NaL into E, or this much charge is ready to cross the conductor whenever you apply the PD. Therefore, free charge is equal to NaL into E. So, we got charge. Now, we have to calculate what is the time taken by that charge to cross the conductor. Even though this much charge crosses the conductor, it is due to the flow of free electrons. So, think that here you have got a last free electron. Now, you may say, what is the meaning of last free electron? To make it simple, actually we have got billions of free electrons, but to make it simple, we consider only 100 free electrons. 100 free electrons are distributed inside the conductor. Out of that 100 free electrons, think that it is the 100th free electron, which is near to this end. This is the 100th free electron. This free electron is following the zigzag path and comes to the positive end. But when 100th electron reaches the positive end, in front of that, there are how many free electrons are there? 99. Even they have to cross the conductor. So, if you calculate what is the time taken by this 100th electron to cross the conductor, within that time 99 electrons they have already crossed, and we come to know what is the time taken. Then you may ask, if 100th electron gone, what happens to current? Current, whether it becomes 0? No, because this end is connected to negative. Here electrons are supplied. Cell is supplying the electrons. Those electrons they enter. Therefore, the flow continues. At one instant I am saying there are 100 electrons, this is the 100th electron, last electron, what is the time taken by that to cross the conductor? So, the method is very simple. Time taken by the free electron to cross the conductor. We know time is equal to, it is the distance travelled by what? Speed. You studied this one in first PU. And here, what is the distance travelled by this last electron to cross the conductor? L divided by what is the speed? Drift speed, because that is the average velocity. It holds good for all the electrons because it is the average value. Therefore, it is mod of Vd. It is the time taken by the electron to cross the conductor. Therefore, now time T is equal to L by divided by Vd. So, we got charge, free charge, and we got what is the time taken by the free charge to cross the conductor. Now, we can calculate current. Current is equal to Q by T. What is Q? N A L into E divided by L divided by mod of Vd. L and L we can cancel. So, it is N A E into mod of Vd. This is the equation for current. Current is equal to free electron density into area of cross section of the conductor into elementary charge multiplied by drift speed. So, equation very important to you. You can expect even some problems in CET etc., and even in the board exam you can expect problem on this, or theory question also you can expect on this.